In a previous video, I solved a conservation of momentum problem involving two colliding objects. In this video, I wanted to expand on that and further discuss the different types of collisions that can occur between two objects. Let's say that there are two objects moving towards one another with the same mass and the same speed. There are actually three different types of collisions that can occur. The first scenario is where, after colliding, both objects bounce back with the same initial speed. This will be the case for two rigid objects that are not easily compressed. Any collision that acts in this way is known as an elastic collision. The second scenario would be where both of the objects bounce back at a fraction of the original speed. This would be known as an inelastic collision. And finally, the last scenario would be where both of the objects stick together and their velocities both become zero. This would be an example of a completely inelastic collision. You might be wondering what any of this means and why this all matters. Momentum is conserved in any of these scenarios. The difference is what happens to the total kinetic energy in the system. In scenarios 2 and 3, the velocities of the objects decrease. This means that the total kinetic energy of the system will also decrease. This is because some of that energy will be converted to heat or some other form of energy. So we can say that there's an energy conversion that takes place in each of these scenarios. In the first scenario, we can see that only the directions of the velocities change. This means that the total kinetic energy of the system will be conserved. In fact, the real definition of an elastic collision is one where kinetic energy is conserved. In problems that involve elastic collisions, we can use the following conservation of kinetic energy formula. Note how this formula looks very similar to the conservation of momentum formula. In any elastic collision problem, this formula can be used along with the conservation of momentum formula to form a system of equations. This allows you to solve problems where the velocities of both objects are unknown. Without this additional formula, you would only be able to solve problems where there's one unknown. Just remember that this formula is only true for elastic collisions. A problem should clearly state that a collision is elastic before you decide to use this formula. If you try using this formula for an inelastic collision, you'll get the wrong answer. I hope that this video was helpful, but if anything was unclear, feel free to comment below with any questions. If this video was helpful, please give it a like and consider subscribing to the channel for more fast physics videos. Thanks for watching.